Hi students, this is Alex here. In this video, we are going to find the Fourier series in the period of 2L for the given function f of x is equal to sin ax in minus L less than or equal to x less than or equal to L. So first we are going to find whether the given function is even or odd. For that I have to find f of minus x. So x is replaced as minus x in the given function and this becomes minus sin ax. So the function becomes negative times of the original function. So it is minus f of x. Therefore, so when it is f of minus x is minus f of x, we can say the function is odd. Therefore, f of x is an odd function. So when it is an odd function, the value of a naught is 0 and an is 0. We have only bn. So bn by formula it is 2 by L integral 0 to L f of x into sin n pi x by L, and here f of x is sin ax. So 2 by L integral 0 to L sin ax into sin n pi x by L dx. We also have dx here. Now we are going to apply the basic trigonometric formula. Whenever we have sin x into sin y, this becomes minus half cos of x plus y minus cos of x minus y. And let's rearrange this keeping the n term as a first term. So this is 2 by L integral 0 to L sin n pi x by L into sin ax dx. So when I apply this formula, this is minus 1 by 2 cos of, we have to add both the angles, that is n pi x by L plus ax. Then minus, we have to subtract both the angle. So cos of n pi x by L minus ax. Then dx. We are going to integrate this. Before that we can cancel these two and minus 1 by L can be taken outside. Now integration of this will be sin n pi x by L plus ax, and coefficient of x we have to divide, which is n pi by L plus a. Similarly, this is minus sin n pi x by L minus ax whole divided by n pi by L minus a. So we have to divide the coefficient of x and we have limit from 0 to L. When I substitute the upper limit, we get minus 1 by L. This will become sin n pi, because L and L gets cancelled, plus al. So we keep this in a separate bracket, divided by n pi by L plus a minus sin n pi minus al by n pi by L minus a. Then when I put a lower limit, both will be 0 because sin of 0 is 0. Now we can expand this using sin x plus y formula. Sin x plus y is sin x cos y plus cos x sin y. So this is minus 1 by L sin n pi into cos al plus cos n pi into sin al whole divided by n pi by L plus a. Similarly, minus, let's open bracket, same thing with minus sign in the middle. So sin n pi cos al minus cos n pi into sin al. For this divided by n pi by L minus a. Now sin n pi is 0. So this term completely 0, even this term is completely 0. We have minus 1 by L into cos n pi So cos n pi into sin al divided by n pi by l plus a minus or minus it become plus. So plus cos n pi into sin al divided by n pi by l minus a. And we can take cos n pi and sin al common. So minus 1 by l into cos n pi into sin al. When this is common, 1 by n pi by l plus a plus 1 by n pi by l minus a. So this is minus 1 by l. Cos n pi is minus 1 whole power n into sin al. And here when I take LCM, it is n pi by l plus a into n pi by l minus a. So here n pi by l minus a plus n pi by l plus a. We can cancel these two, and now we can take n pi by l addition. So minus 1 by l minus 1 power n sin al. This is 2n pi by l whole divided by, this is a plus b into a minus b, so n square pi square by l square minus a square. So here we can further rearrange minus 1 into minus 1 power n sin al 2n pi whole divided by, this l and l will become l square, then denominator l square n square pi square by l square minus a square. We can multiply this l square inside of these two terms. So this is minus 1 into minus 1 power n sin al 2n pi whole divided by n square pi square minus a square l square. This is what we get for Bn. And further, we can combine these two powers. This is minus 1 power 1, this is minus 1 power n. So we can combine it as power n plus 1. So finally Bn is, we can write the number 2 in the beginning, or we can keep that as it is also, not a problem. So minus 1 whole power n plus 1 sin al into 2n pi whole divided by n square pi square minus a square l square. So after getting this Bn, we have to substitute in the Fourier series expansion formula, which is f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by l plus summation n is equal to 1 to infinity bn sin n pi x by l. Since a0 and an is 0, we have only the last term, summation n is equal to 1 to infinity minus 1 whole power n plus 1 sin al into 2n pi whole divided by n square pi square minus a square l square. Now 2 is constant, pi is constant, and sin al is constant. So all this thing is taken out, sin al. Then summation n is equal to 1 to infinity minus 1 whole power n into n by n square pi square minus a square l square. This is the Fourier series expansion for the given function f of x. And sorry, this is power n plus 1. And also at the end we have sin n pi x by l into sin n pi x by l. So this is our Fourier series expansion.